so again. What is all this we're talking about? Pyruvate. You'll hear these names when you're studying biochemistry, and you'll see the glucose. Glucose is 6 carbons, right? The first reaction that happens is it breaks it in half. 2 pyruvates. Well, this is a powerful teaching tool because see the 3 carbons. A methyl group out here, double bonded oxygen, single bonded oxygen, single bonded oxygen. This technically would have them both the same distance apart, but we'll leave the old traditional structure the way it is. It would be like this, is the more correct way, because it's ionized, the hydrogen's not on it, so these are both the same distance away. That double bond is shared between them. But for general introductory purposes, they draw all the electrons on this oxygen. So the point is, if you picture this now, his methyl tail, double bond, single bond, lots of electrons out here, right? So the pyruvate, you end up with 2 of these. What do we need to do in our body? We're trying to get energy, so we need to break these down. And how do we know what happens next? I mean, there's a whole citric acid cycle, the Calvin cycle, all these different things going on that are confusing. So what I like to do is take all those drawings that enzymes like Rubisco, when you're building sugars, or to follow what is actually happening in each step, make a little animal out of it. So here's the pyruvate tiger. Let's see what lactate. So, see the lactic acid tiger? What do we call him there? Rudolph the red-nosed lactate. Now lactate, lactic acid, that's when that proton is come and gone. So when we're looking here, look here now. There used to be a double bond on the pyruvate tiger, right? So if we have this picture next to pyruvate, we see that the double bond on the head stayed the same, the methyl stayed the same, the OH, whether it's protonated or not, which down here is, this is a drawing I would draw as the chemist, okay? Double bonds stayed the same. There's the methyl, gives them a different face out there. Rudolph looks a little different here. So you can take it any which way you want it. But what I remember is that oxygen had a double bond on it, right? So that is where the first reaction from pyruvate to lactate happened there. And what happened? A double bond went to a single bond, so some electrons had to come. There's probably another hydrogen out here now if you were going to draw this correctly. This has a double bond on the tail. So if you drew it backwards, you're still able to follow where the double bond is. But there's only one now. Remember, pyruvate had 2. So this really, in my opinion, my expert opinion, makes it a lot easier to follow a chemical reaction when it's a cartoon. And I think I see no reason in the world why 4-year-old kids, if you're coloring a coloring book of Smurfs that are totally make-believe, why can't the little kid be coloring a pyruvate tiger going to a lactate tiger? You could have something come up and, I don't know, bite his tail off or something. That'd be a good one for methylations, huh? Whenever you have a D-methyl, what do you call it when you're taking a methyl away? A methylate, methylates is a demethylate, I guess. So if you're taking a whole methylate away like that, you could have some kind of centipede or something come up and chomp his head off. There's a lot of potential for fun with this chemistry art, as I call it. And there's no reason in the world, the younger the kid, they can't learn it. Hey, it's Cosmic Ray, the quantum mechanic. I'm back here to show you some alpha particles, alpha fishies. Remember what the astronomers love to say is that the sun makes helium. It takes 4 hydrogens and makes a helium. Well, a helium is only 2 protons. So the sun makes neutrons to begin with. Without the neutrons, the protons aren't going to stick together. So what happens now is an alpha particle. This is what a helium is, helium-4. There's a helium-3, but that's not what 99.999% of helium is. Helium is an alpha particle. So with 2 protons, 2 neutrons, it has a mass of 4. But 2 protons gives it a +2 charge. So a helium will carry 2 electrons, a neutral helium to balance that out. Electromagnetic is 1 force, so 2 plus 2 electrons. But in stars, there's no electrons because these things are so highly energized and they're moving so fast and they're charged, and they were created in situations where the electrons just weren't even allowed into place. Only big, massive things were. So the beauty of this is helium alpha. It's called an alpha particle. Well, if you see the Christians like to use the alpha fish, someone said it because it was a fish, but I think it's because he's the alpha and the omega. Well, the alpha is the beginning of the alphabet. So the alpha is the fish. So if you think about it, all the bigger elements are made from alpha fishies. So if you look at the chart of the nuclides, not the periodic table, you're going to find 2 heliums would be a beryllium-8. Beryllium doesn't exist as an 8. Beryllium exists as a 9. So what the star has to do is get a super excess of helium, super condensed in the core up to 100 million degrees, 10 times of what our sun is now, is what a star needs to be. And what it'll do is a triple alpha process. 3 alphas will come together, and you know what element that creates? The element that you hear is most essential for humans, the one that I say it's not just that, it's that, nitrogen and oxygen also. Carbon-12. A carbon-12 atom is 3 alpha fishies. It's 3 helium particles that were made. And you know what's neat? If you add another alpha fish to a carbon-12, you know what you get? Oxygen-16. That's a pretty popular molecule too, huh? Atom. Oh, I called it a molecule. The old-timers used to be able to get away with that. You could, if it was a single atom, you could call it a molecule if it was in a stable form, like a noble gas. A noble gas, you could call it was a molecule because the physicists were at liberty to do that. But I'm not. There's no excuse for that. Oxygen-16 is an atom. Add another alpha particle to oxygen-16, it would give a mass of 20, a proton count of 10, neon. So carbon-12, oxygen-16, neon-20. All those are alpha particles building bigger atoms. So see what it is here. The alpha fishy, 2 neutron bunnies, and 2 protons. 4 particles, 2 bunnies, 2 protons. 3 alphas together, carbon-12. 4 alphas together, oxygen-16. So I think it's cool. We'd call these starfish. As the atoms grow bigger, you can kind of picture it as a bigger fish. So what comes in here? Here's a big oxygen-16.